I really think you should. All right, so here we go. I'm not very good at math, but you know what? I think I can do these. At least I hope I can. I think I can. All right. Horizontal asymptote. How do you find the horizontal asymptote? What are you looking at? Degree of the exponent on top, degree of the exponent on the bottom. Now, you can't tell what the degree is until you multiply it all out. The top piece is going to... Thank you, Miranda. They are the same. The top piece is going to be x squared. Bottom piece is going to be 2x squared. So, once they are the same, what do you know about the horizontal asymptote? Everything else is irrelevant. And you're going to write it as y equals 1/2. Right now, for those of you that have this written down, you better squeeze in. I know y'all do it. Y'all lay it. I had it. Okay? You just squeeze that little y in there somewhere. No, it's got to be y equals. If you forget the y equals, don't worry about it. I'll put it for you.
Why?
Because
it's the only thing I forget.
That's what you forget?
Yes. Oh.
You'll forget once or twice. Okay? All right, vertical asymptotes. How do you find the vertical asymptote? You set the bottom equal to 0. So in this case, you get x equals -5/2 by setting this piece equal to 0. And +8 by getting this piece equal to 0. You got to do both.
And we can write it just like that on the test?
Yeah.
Okay.
As long as you put x equals.
Oh, I have x equals right in.
Yeah, you don't have to separate the two x equals.
Okay.
Now, the x-intercepts. What's the x-intercept? The x-intercept you find by setting the top equal to 0. So for that, you're going to set x minus 4 equal to 0. X plus 3 is equal to 0. Your two x-intercepts are going to be 4 and -3.
So, will it come like that? You don't have to put the negative first?
No, it doesn't matter. For the y-intercept, you set x equal to 0. So you're going to get -4 times 3 over 5 times -8, which is -12 over -40, yes? I don't know for sure, but I think that's 3/10. Okay. We straight on that. So,
We don't put, okay. So
You
we
can-
don't need to put x, y.
no, you can put 0 3/10 if you want. Make it ordered pair.
And for the x one, we don't need parentheses.
You would do 4 0 and -3 0 if you were going to do an ordered pair.
But you don't have to.
No.
Okay.
Okay. Miranda does not want to do anything extra.
I'm with her.
Yeah, I am too, actually. All right. Any questions on that? All right, now, for this one, this is where we ended off last time. So this kind of encompasses the discussion we were having as class ended last time. What did you get? Haley, what did you get?
What did I get for which one? Like greater
The
than
first
or
one.
less than?
Greater than.
Greater than? Let's see. Where is this? Oh, okay. I got parentheses, negative infinity to -3, parentheses, union, parentheses, 5 to infinity, yeah.
Negative infinity to -3, union 5 to infinity. And we're back. So, all right, now when's it less than 0? You know what we need to do? We need to figure out, like, Martin's answer.
My answer?
Yeah, Martin. Your answer.
It's less than it from -3 to 5.
From -3 to 5. We straight on that? Now, Grace, I know what you're thinking. He's about ready to call on me. You're right. Grace, what'd you get for this one?
I don't know if it's right, but for greater than, I got negative infinity to -3, union 5 to infinity.
Union 5 to infinity. Now, Grace,
But I don't like that one because I want to know where that intercept is. You didn't label it.
what intercept?
The one that from the 5 to infinity is almost touching.
Oh, that's y equals 1. Y equals 1. Horizontal asymptote. Now, Grace, let me ask you a question. You weren't certain about this one, is that right? Did I hear that correctly? I mean, you got an answer for it. You're not, if I say, would you bet $1,000 that's right, you would say, no? Okay.
I'm not a big gambler.
Okay. Grace, let me ask you a question. Would you bet $1,000 that this one is right?
Yeah.
So this one is like, on a scale of 1 to 10, you're a 10. You know for sure that's right. On a scale of 1 to 10 here, you're like a 4?
I'll bet 7 or 8.
An 8. See, 4 is the new 8. So you're more than 50-50, but yet you're not certain of it. Okay. Charles, what'd you get for the second one? No solution. That's not a bad answer. Not a bad answer. No solution. Not the answer we're looking for, though. Jessica, what'd you get?
I put -3 to 5,
And Jessica, how certain are you about that?
probably about an 8.
You're an 8. Now, Jessica, let me ask you a question. What'd you put for this one?
-3 to 5,
And how certain are you about that?
10.
Are you just cheating off of Grace's answers? I mean, you're a 10, she was a 10, you're an 8, she's an 8. Okay. Well, let me ask you a question. Look at the two answers. What do you notice about the two answers we came up with? It's supposed to be -3. I think Grace said -3. I just didn't copy it down. Now what do you notice about the answers? They are identical. Now you're probably asking yourself, okay, thank you, Captain Obvious, and who gives a crap? Okay? Well, here's the thing. If I ask you, when is x plus 3 over x minus 2 greater than 0? You know you have to graph that. If you solve that any other way other than graphing, you're probably going to get it wrong. Okay? If you do this, this is absolutely 100% god-awful. If you do that, and you multiply both sides by x minus 2, that is unbelievably bad. Like, there's bad, there's terrible, there's god-awful, and this is somewhere worse than that. Okay? You cannot do that. What you have to do is graph. So what does this look like? Well, now here you are trying to figure out the vertical asymptote, you're trying to figure out the horizontal asymptote, you're trying to figure out the x-intercept, you've got to figure out the y-intercept. Once you do all of that, then you can get a graph, and then you can try to look at it and figure out when it's bigger than 0. However, what does this look like? What does this graph look like? It's a parabola. It's a concave up or down. It's concave up. Where does it cross the x-axis? -3 and 2. So if I want to know when is this greater than 0, what's the answer? Negative infinity to -3, union 2 to infinity. So now my question is, earlier we said that these two answers were the same and these two answers were the same. That this being greater than 0 was the same as this being greater than 0. And this being less than 0 is the same as this being less than 0. So the question is, will that always be the case? Can I say the answer for this is automatically the answer for this? Because if it is, I'll just write that down. And I'm done. Forget the vertical or horizontal asymptote and all that other nonsense. Now the question is that always the case? Yes?
Remember last week when we did the A over B is greater than 0, and then the A times B is greater than 0?
What did we say?
Well, we said that if A times B is greater than 0,
If A times B is greater than 0,
then A over B is also greater than 0.
this is always true. This is always true. So therefore, that allows me to take this problem and not look at it as division, but look at it as multiplication. Now, why would I want to do that? Well, because if somebody said to me, hey, you have to graph 3x plus 4 over 2x minus 5 and figure out when that's greater than 0, I go like this. I don't want to graph that nonsense. I'd much rather graph a parabola. It's much easier. 3x plus 4, 2x minus 5. That corresponding parabola will have the exact same answers. It's just easier to graph. Does everybody see that? So all I got to do is figure out where these points of intersection occur. Once I figure that out, then I have the answer. Okay? Does that make sense? All right. So let's stop